So we have some basic properties we'll use when evaluating indefinite integrals. If we have a constant in front of our derivative, then we'll have a constant in front of our antiderivative. If our indefinite integral, involves a sum or a difference, then our antiderivatives will be separated by a sum or a difference. So let's do some examples below. So here in the first problem, we have 1, 2, 3 antiderivatives we're going to solve. Remember, normally when we have the power rule and we're taking the derivative, we multiply and then subtract. So to work backwards, we're going to add and then divide. So this becomes x to the 3 plus 1 divided by 3 plus 1 plus x to the 2 plus 1 divided by 2 plus 1 minus 3x to the 1 plus 1 divided by 1 plus 1. And remember, there's actually a 0 added on the end here, so that means its antiderivative could have been a constant. So don't forget that c. So this simplified is x to the 4th over 4 plus x cubed over 3 minus 3x squared over 2 plus c. And remember, you could take the derivative to check your answer. So take the derivative to check your answer. So 4 cancels with the 4, that leaves x cubed. 3 cancels with the 3, that leaves x squared. 2 cancels with the 2, that leaves 3x, and the derivative of c goes away. So my answer is correct. Let's try another example here. So now we have the sum of 3 different terms. If 4 is a constant, that means its antiderivative must have been 4x. X to the first power becomes x to the 2 over 2. So I was doing this type of work in my head now. And then what's the antiderivative of secant squared? Secant squared is the derivative of tangent, so this must be tangent x. And then don't forget there's a constant of 0 here, plus c. Here in number 3, we are going to have to manipulate a little bit more first before we can start to find that antiderivative. So I'm going to distribute, and that becomes 3x plus x to the 3rd dx. So now I can use my power rule for the first one, 3x squared over 2, because this is 1. And then this becomes plus x to the 4th over 4. And then since there's a 0 here, plus a constant whose derivative could have been 0. And last but not least, here in number 4 on this page, what's the antiderivative of e to the x? E to the x. What's derivative is 1 over x? Well, that is ln, absolute value of x. Which derivative gives you sine x? Well, the derivative of cosine x is negative sine x, so this has to be minus cosine x. And then the antiderivative of cosine is sine x, and then don't forget your plus c, possible constant, whose derivative could have been 0. So antiderivatives work backwards, and this indefinite integral tells us to find the antiderivative.